Okay, hello and welcome. This is Chuck Young with EASA, the Electrical Apparatus Service Association. I'm the Senior Staff Engineer with EASA. And what's prompted this webinar, of course, are the events down along the Texas and Louisiana Gulf Coast, in this case with Hurricane Harvey. The title here is, and the subject is going to be disaster recovery, what to do after the storm. And of course, when we look what the problem here is, the rainfall in this case, or back during the Katrina and Ike storms, it was a storm surge, but in just unprecedented amounts of water. The rainfall with Hurricane Harvey was actually twice what was experienced with Katrina, and of course the flooding is even worse than what was experienced back during Katrina. So if you look at the amount of flooding that we would have, not only in residential areas, but also in plants, it can be really quite a mess and very expensive. A few comparisons here. The average hurricane cost is about $7 billion U.S. Hurricane Katrina was over $250 billion, with 1,800 lives lost. The numbers in terms of loss of life appear to be much lower with Harvey, but in terms of economic cost, we're hearing estimates possibly as high as $1 trillion. So if we look at the impact of these hurricanes to the Texas and the Gulf Coast, in this case, the refining capacity of that area really concentrated just south of Houston and on up through Lake Charles, Louisiana, is roughly 28% of the U.S. total. Over 400 petrochemical facilities that were directly impacted by this storm. And of course, these plants are anxious to get back up into operation and start producing gas and all the things that we use every day all across the country. But one of their issues is that most of their employees are also flooded. So human nature being what it is, we all want to take care of our families, and loyalty to company is great, but loyalty to the family trumps that, or it certainly should. Not only that, but the supply chain is experiencing the same exact sorts of problems. We have employees of companies that are flooded, and those employees are also flooded in many cases. Shipping is difficult, if not impossible. Barge traffic can completely be stopped because of all the issues with what's floating around in the rivers. Lack of power, loss of potable water. The city of Beaumont, Texas, lost both of their water treatment plants. So we're looking at places that will be operating with very limited infrastructure, possibly for quite some time. So one of the first things we have to do is look at what kind of pre-event planning could have been done, and not to a finger point, but mostly to look at it and say, what can we do so that this isn't so catastrophic next time? Prioritize equipment. Which kinds of equipment are special and require repair, and which kinds of equipment can simply be replaced, either at a more cost-effective basis or at a much more rapid basis to get back in service. So prioritizing the equipment so we have an idea of what we need to repair, where we're going to send it for repair, and which sorts of things we can replace. So we need comprehensive ideas of what equipment we have that's going to be affected by the storm. Even place order lists with pre-selected vendors. In the case of a major event, we can pull the trigger and place those orders rather than waiting around through the plant trying to document and figure out what we need. Leverage your inventories, your vendors rather, to carry inventory. So bearing houses, fuses, electric motors, those kinds of things. One of the things that's really easily overlooked is that if we're going to have to do a major repair to the whole plant, then let's move everything that we practically can above flood stage. Switchgear rooms, motor control centers, those kinds of things. Anything that we might store for emergency use in a future problem, let's make sure that we've put that in an area where there's a lot less likelihood of it flooding. So those are things that are going to help us in the long run. If you look at this map or these series of maps, you can see that this isn't just an East Texas kind of an event. Indian Ocean, tsunamis, devastating. The tsunamis that we've seen hit coastal India and Malaysia. There are a lot of areas of the world that are experiencing the same sorts of events occasionally every few years where it can be catastrophic, not in terms only of loss of life and cost, but in terms of lost productivity. So one of the things we want to do, and you said, is prioritize our electrical equipment. If we have older standard electric motors up to some certain horsepower or cost, then let's replace those with premium efficient motors. We have to replace them anyway, so let's replace them with premium efficient motors and have a positive impact on our operating cost. Look at the size of the machines and the criticality. You may have a small motor that's relatively inexpensive and yet is highly critical to the operation of the plant. Conversely, you're obviously in most plants having machines that are large enough that there may be a year and a half or 2 weeks or 2 years or even longer replacement cost or time. So the delivery time may be 18 months, 24 months. So in those cases, obviously repair is going to be the more logical choice. The local vendors who you deal with for electric motor repair, for switchgear repair, for purchasing supplies and so on, many of those, if not all, are also going to be affected. So we need a secondary set of potential vendors far enough outside the affected area that they'll still be in service and operation, and you can work with those. Switchgear, just like electric motors, evaluate the availability, the lead time to get replacements, and the cost, and do the same sort of thing with switchgear that you do with electric motors. But unlike an electric motor, which in many cases is mounted pretty well at ground level because of the way the structure and the piping and so on in the plant is built, a lot of that switchgear could have been permanently installed in a room basically on the second floor or certainly above flood stage. Fuses. These are something that are easily overlooked. When I spoke with a plant after Katrina, one of the engineers commented that for them it was a real eye-opener. They had 70,000 fuses in their plant. Not that a vendor wouldn't like that order, but it's hard to imagine anyone who you could call up and place an order for 70,000 fuses in assorted sizes and get those in a timely manner. So one of the things we need to do is to develop an emergency response team, figure out which people are familiar with the equipment and obviously willing and able to work probably very extended hours. So divide teams up. Who's responsible for replacement? Who's responsible for getting stuff out that we have to send out for repair and getting that repaired? So that decision, replace versus repair, seems very straightforward and logical, but sometimes the things we think we can replace turn out to not be available. Maybe they're obsolete equipment, or you are looking at extensive modifications to make something work. So it's important that the stuff we're going to replace, the electric motors, the switchgear, and so on, be staged in some area that's convenient but well out of the way, so it's not an obstacle to all the repairs that are going to be going on. And that may be a large parking lot area or someplace where we can stage things so that if we discover that something's not available to replace in a reasonable time, we can pull that out and move that from the repair or to the repair side of the equation. Coordinate the shipping. You are going to be dealing with out-of-area vendors in many cases for bringing equipment in. If you handle and coordinate the trucking yourself, then you can ship materials that are going out to be repaired, and on the return trip, bring back the sorts of things that either have already been repaired or are going to be replaced. We may have to have inspections by the insurance companies to make sure they pay for that. And we're going to talk about the insurance companies in a minute, and I'm not saying they're going to squirm, but they're things we need to look at. So the first thing is, how do we keep the employees, all the people who need to get all this work done, how do we keep them housed? Temporary housing, because their homes may well be flooded. So if you look at the possibility of using a barge with mobile homes, cruise ship. Believe it or not, a lot of the cruise ships that operate out of the same ports that are in the areas affected by the storm are likely to have mass cancellations. So you may have a cruise ship available with hundreds of cabins, and it solves a lot of problems. Not only can you get the individuals who you need in the plant taken care of, but their families can move into this same cabin with them. So now you've taken one of your employees' concerns off the table. The family's now being cared for. Cruise ship already has potable water, has water treatment plants, it has onboard power supplies. So everything that they need to live temporarily and not have to be living in tents or RVs or campers is available on the cruise ship. So you solve a lot of problems for your employees, and you're going to be able to have them there to help you get everything squared away. So that's certainly a good way to go. A barge with a mobile home, not as nice, it's functional. Shipping containers as bunkhouse, that's certainly down the list a few. Merchant ships in some cases are a possibility. You'll recall after Katrina, FEMA brought in a large number of campers and RVs for people to live in as temporary housing, and those are really just designed to be temporary housing. So there were health issues with people living in them for long term, for a year or in some cases several years. So those are things to look at. Merchant ship may not be ideal for housing a lot of people, but it certainly gives you the possibility of ship-to-shore power so that you have a backup generator of a pretty high kVA capability to help you run the plant. So if we look at electrical equipment, one of the things we have to do with electrical equipment is to look at the electric motors, generators, transformers, switchgear, fuses I've mentioned, the MCCs, the motor control centers, and cable runs. And each of those lend themselves to our looking at it and seeing what we can do and what's not practical. So if we look at electric motors, if it's a rust caused by saltwater issue, when we look at a rotor and the stator core, if we have saltwater penetration and the salt water is allowed to dry, then the salt is there to stay. We can clean it and soak it, but the rusting process that's started by that salt water being soaked into the cores is irreversible. So yes, we can clean this very large electric motor and dip and bake it and get it back into service with new bearings or refurbished. However, we have to recognize that the rusting that we're looking at in this picture is irreversible. So if we look at the vent duct, the airflow through this rotor comes through the underside and then is expelled out through these vent ducts. So the upper portion, we can see missing laminations. We can see swelling of the core here. but the underside of the rotor, if we look down deep beneath these vent ducts, the underside of the rotor is, in most cases, more swollen, more damaged, and restricting the airflow far more than what we can see here on the surface. And as you can see, what's on the surface doesn't look good. So we need to recognize that the motors that we're repairing, if they've been immersed in salt water and allowed to dry, are going to need to be replaced. We may be looking at a 5 to 10 year remaining service life, if that. So if we can get motors in and immerse them in fresh salt water, if you have a lake close by, a large swimming pool, heavy dumpsters, any sort of a holding tank that's not being used for something else, we can clean the electric motors and generators and immerse those in water. So if you look at this next slide here, the cleaning of electric motors and generators, this is just showing a simple tank, but a swimming pool, a dumpster, a very large tank being used for overflow chemicals that is empty and reasonably clean. Anything like that you can use to place as many electric motors as possible in, flood them with fresh water. In a perfect world, we want a water inlet so that we're circulating and pushing this fresh water through and hopefully flushing as much salt water out as possible. 5 to 10 liters a minute is a reasonable exchange of water to flush through here, and then as the service shop is able to get to the electric motors, you pull out, dismantle, pressure wash, clean, bake, and get rid of the salt water. So this tank full of fresh water is just here for the purpose of avoiding the salt water actually being allowed to dry. So now, next slide, cleaning of electric motors and generators. A typical service center, the bottleneck is the bake ovens. So we have possibly 14,000 electric motors in a plant that I'm thinking of in Deer Park, Texas, in one plant. To run all those electric motors, some of them quite large, as the one you see here on the right side of the slide, to run all those through and pressure wash them and then process them through a bake oven to dehydrate them, a stator this large might take 10 or 12 hours to fully dry to remove all the moisture. So the bottleneck is the bake oven that's being used to do that. There are home construction materials available at the large box stores that we all go to for home projects. The hard foam board with aluminum on both sides can be very easily duct taped onto a stator. The one on the right is shown in the image here, and we can use supplemental heating. That may be space heaters, it may be the salamander or torpedo blower that you see on the right, in order to push hot air through this and dry the windings effectively and efficiently without tying up the shop's single bake oven for 10 or 12 hours to dry it. So pretty simple process. If you're familiar with wood stoves, we're just using openings cut into this aluminum board so that we can control the rate at which the air flows through and control the temperatures. Larger machines like these, in most cases, particularly with the petrochemical industry, are fitted with winding RTDs. So we can tell when the winding is up to temperature, so that's pretty helpful. Transformers, another big issue. Not as big an issue as you might think at first blush. The dry type transformers, as we see here, the process just like to do the electric motors. The windings are exposed. If they've been immersed, then they'll need to be flushed in the same manner and cleaned and then dried out. The larger transformers, the big oil-filled transformers that we see in plants, and some of them quite large, you see here in a substation, It's probably only the exterior of the transformer that's been immersed, that has water in it. We can do dissolved gas analysis to check for water for transformers, and there's nothing here in this slide, but for transformer oil, the recommendation is not over approximately 35 to 38 parts per million of water. So that can be analyzed and checked to determine if we need to do something. External cooling tubes, the outside of the transformer needs to be cleaned to make sure that we've flushed off any salt residues that might cause rust down the line. Any rusting that's present, we want to clean it, melting and repaint. Transformer oil is expensive, and it's one more thing to ship in, but it's a routine process for the large transformer rebuilders to run a special filter and circulate the oil through the special filter to remove moisture. So if we look at the next slide, we can use a heat source to dry the transformer. A very popular way to dry a large transformer, is the one in the picture previously, is to circulate hot oil through the unit. So heating the oil to approximately 85 degrees C, circulating hot oil through the transformer should flush out and remove the moisture. So that's a pretty easy fix. In a pinch, one method for producing heat inside the transformer is to close the secondary of the transformer. In other words, to actually short the three-phase leads of the secondary of the transformer together, and then apply reduced voltage to the primary of the transformer. And by that means we generate enough current and heat to heat and help dry this. Transformers built after approximately 1965, as part of their construction, were braced for full vacuum. So that means that with that type of transformer of that vintage, you can drain the oil, filter it separately, pull a full vacuum, and evacuate the moisture. So paper phase drying is preferred. If you can hit about 35 cores with a vacuum, introduce hot fluid, hot oil, and flush that through to absorb the moisture, then you're usually able to clean the transformer and dry it pretty effectively and remove the oil. So what about distribution transformers? A cold trap, which is the common means of removing moisture from a large transformer, is basically a still. So if you think of that as a still, it's a way to circulate through and distill the water out and put dry air back into the transformer. Define dry, well, the industry pretty well agrees that it's less than 40 grams of water being distilled out within a 6-hour period. We can do additional tests. DC insulation test, the megometer test. We can do a polarization index test. We can look at power factor and power factor tip up. So these are pretty routine electrical tests for the large high voltage transformers, and those can be very helpful in determining whether we have a problem or whether we're able to clean things up. What about the electrical cables that run from the transformers out through your plant to the motors? Which ones do we need to worry about? Well, as it turns out, the people who manufacture cables are way ahead of us. Any cable that's suitable for what locations, underground conduit, that sort of stuff, direct burial, are going to have the W in the type. So a TW, the THW, THWN, etc. If it has a W in the type, it's suitable for use in a what location. So you're probably okay. If we have conduits run underground, they almost certainly have water in them. So that's going to have to be blown out with due diligence paid to the other end of the conduit, so we don't blow 500 gallons of water through and soak the motor control center and cause all sorts of other issues. Direct burial cable will be designated UF or USE. And if it's exposed to salt water, you can expect it to degrade, to deteriorate due to the corrosion. In most cases of these types of things we're looking at here, one thing that's a pretty simple procedure is to use a dry nitrogen tank, connect that through a pressure gauge and regulator, and low pressure dry nitrogen literally being pushed through the cable. So you can push cable quite long distances. This is something you may even see in rural areas way out in the boonies, where you'll see a nitrogen tank standing there beside a power line, where they're using dry nitrogen to just push dry nitrogen through the cable and keep it dry. So pretty simple thing to look at here. The money, capital considerations. Any electric motor or generator that's been immersed in salt water, if it's been allowed to dry or if it's not very, very thoroughly cleaned, you can expect the laminated core life to start deteriorating. In an emergency like this, certainly getting them cleaned and back in service gets you back in production, but you need to recognize that you need to budget and plan for replacement of many, if not most, of those electric motors and generators within the next 5 to 10 years. So these motors are going to rust and continue to rust if they're immersed in salt water. The same's not true if it's fresh water. So if it's a rain event and it's not a mixture of salt water and fresh water, then cleaning, processing, getting back into service, you should be in good shape. But if it's a saltwater event, a high tidal surge, for example, then a lot of the equipment, and some of it's quite expensive, will need to be replaced within about a 5 to 10 year period. That's something that you need to work with your insurance providers for. At the time that you're looking at getting back into service, somebody further up the food chain is working with the insurance companies about lost business insurance and those kinds of things that you may or may not have depending on the company. But make sure that you've given the insurance provider a head up that you expect in the near future, by near I mean 5 to 10 years, that you expect that it's very likely that some of these electric motors and generators and possibly transformers will start failing, and that the result of this storm now is those failures in the future. So keep that documented and do your very best to make sure the insurance company recognizes that this claim's not closed a year from now when your plant's back in service. This claim may be continuing to generate losses for you, for your company, and consequently is to them. Future construction, as mentioned earlier, if we can move the motor control centers and the switchgear above flood stage, very simple thing to do. If we've got a room the size of a trailer and you can elevate that on stilts and put a staircase up to it, we can still concentrate our MCC so that all the switchgear and so on is together for testing purposes, for cleaning purposes, for the ability to air condition the room and keep the operating temperature and climate control it. However, if you build that stuff above the stage, you won't be in the same boat as you are in this failure, or perhaps were in the previous failure. So with that said, we'll move on to the last slide here. Things to look at. Local vendors, again, they're in the same boat you are. They may have lost power. They may have employees who are more concerned with taking care of their families than with taking care of the business that you need. So work with your local vendors. Try to get some sort of team building going between them and alternate vendors who are further distance inland and away from your expected area of problems. If you're dealing with a large company with multiple locations, That certainly simplifies that process, but that's not essential. You can work out partnerships with a vendor who's perhaps 300 miles away and is not going to be impacted by this storm, or hopefully is not. Expect that you're going to see longer delivery times. Expect that the service center that's cleaning your electric motors may be absolutely inundated with work. They may have hundreds of motors waiting out in the parking lot to even be brought in to where there's workspace to work on them and clean them. And recognize that if you're in an area like the Houston area, Bay Area, Lake Charles, Louisiana, through Beaumont, many of these places look like a subdivision of chemical plants rather than homes. So there are a lot of other plants in the same condition you're in, and everybody's going to be competing in those resources. So a good relationship with the service centers you deal with, absolutely critical. Work with service centers and establish some kind of a relationship in advance and pre-qualify service centers who are close enough to you that they're not terribly inconvenient, but far enough away that they're hopefully outside of the area impacted by the storm. And again, coordinate with those other service centers to see what can be done in terms of getting a relationship, in terms of coordinating trucking. Many of those service centers have their own trucking capabilities, so it may be that when they're coming to your plant to pick up electrical equipment to be taken and cleaned, that they can deliver materials that you're ordering for your own cleaning purposes. So minimize the number of trucks on the road. And the next slide here. There's sort of a graying of our industry. You know, we have that institutional knowledge of the experienced personnel who've been there for 30 years, and they know everything your plant needs. Now you're asking those personnel to work 60, 70, perhaps 80 hours a week. So they're going to be strained. They're going to be exhausted. You have to avoid overworking people. You may be able to bring in local resources. Some of the cleaning things that need to be done are really grunt labor. You may not need highly skilled personnel, but you need personnel who can take instructions and understand what needs to be done. Plan ahead, absolutely. Do what you can to figure out which equipment really should be repaired, which equipment should be replaced. There are certain equipment that you may think you can replace, and you find out that it's obsolete equipment and it's going to have to be repaired. So staging the materials and the equipment that's pulled out of service so that you can find it when this is all said and done, when suddenly someone calls you and says, oh, no, there's a 3-year delivery for that particular transformer or item. So you can lay your hands on it and get that back into the repair pipeline. Coordinate your shipping. Again, if your truckers are carrying things both ways, then you're probably cutting your trucking costs almost in half, so that's beneficial. Figure out what you need to carry in inventory. Identify replacements availability as best you can, as well as possible. The fuses I mentioned earlier, that was a real shock to me when an electrician told me that they had 70,000 fuses in their plant. And there are very few cases where the fuses and fuse boxes and disconnects, there are very few cases where those couldn't be positioned and coordinated in a room that's above flood stage, that's on the second floor or even higher. So there are very few cases where you can't do that. So it's certainly a less daunting task than it is to try to send somebody through the plant and order and replace 70,000 fuses. So next slide here. If you're an EASA member and you need any technical help as far as disaster recovery or anything else, cleaning, how to do certain things, where to find parts, those kinds of processes, contact EASA Technical Support, 314-993-2220. Go to the EASA website. As you can see here, EASA.com, resources, tech support, or you can email the EASA engineers directly, and we'll help you in a timely manner. And that's all we have for this session. Thank you very much, and good luck.